Today we will discuss about limit. So first of all, what is the concept of limit? So in order to explain that concept, let's say suppose I have been given a function as fx is equal to x square minus 1 divided by x minus 1. Okay, this is my function, and I have to explain that what will be the behavior of this function near x is equal to 1. You may think that let's take common factor x minus 1 from numerator and denominator and make it fx is equal to x plus 1 into x minus 1 by x minus 1 and then divide these two, so you will get x plus 1. So I can say that near x plus x is equal to 1, my f of 1 will be 2, that is, you can say like this. Then you are wrong. Why you are technically wrong? Because the moment you go near x is equal to 1, what has happened? Your x minus 1 has become 0 and division by 0 is not allowed. So you can do this simplification for all values except x is equal to 1. So what I can say is that this fx is equal to x plus 1, I can write it in this way for all x except x is equal to 1, that is x should not be equal to 1. If x is not equal to 1, then I can write fx is equal to x plus 1. Then you can say what will be when x is equal to 1? In that case I will say this function has not been defined, so this is an incomplete definition because the question does not give me the answer that what is the value of this function at x is equal to 1. Now it depends upon the question setter what value he chooses to give to this function at x is equal to 1. But the question never asked you to find value at x is equal to 1. It only said what will be the behavior of this function near x is equal to 1. So I can say that near x is equal to 1, this function will behave like this, fx is equal to x plus 1. If I draw graph of this function, I can draw it like a straight line of fx is equal to x plus 1. Only care I should take is that at x is equal to 1, I have drawn this vacant point. Why this vacant point? This is to signify that x is equal to 1, my fx is not defined. At least this question does not give me the definition or the value of fx at x is equal to 1. So let's find out what will be the behavior near x is equal to 1. So I can make a table. I can, you see, for values of the closer x gets to 1, I can say the closer fx gets to 2, but not exactly equal to 2. So value of x below and above 1 will be, say for 0.9 it will be 1.9 because fx is equal to x plus 1 for all x given by this condition x not equal to 1. For 1.1 it will be 2.1, for 0.99 it will be 1.99. So what you can say, as I am going closer and closer, suppose this is my 1, as I am going closer and closer to 1, my value is going closer and closer to 2. Similarly, as I am going closer and closer to 1 from right side, that is from above 1, that is from 1 plus point, then also it is going closer and closer to 2. So when I draw a curve, now this point fx equal to x plus 1, so for x not equal to 1, this is x plus 1. So I can say that this 2 is my limit. So this is the definition of a limit. I will define it in. So the limit is, suppose fx is a defined function defined on an open interval about x naught, except possibly at x naught itself. You see, in my example also that fx is equal to x square minus 1 by x minus 1, the function was not defined at x is equal to 1. Even then, I found the limit at x is equal to 1. So first concept, you should get it very clear, that for definition of limit at a point x naught, the function may not be defined at that point x naught itself. Okay, so if fx is arbitrary close to L, as close to L as we like for all x sufficiently close to x naught, in this example x naught was 1 and L was 2, we say that f approaches the limit L as x approaches x naught and write it like this: limit x tends to x naught, fx is equal to L, and which is read as the limit of x as x approaches x naught is L. For instance, in this example fx approaches the limit 2 as x approaches 1, and we write limit x tends to 1 fx is equal to 2, or limit x tends to 1 x square by minus 1 divided by x minus 1 is equal to 2. So this is the definition of limit. You can say why this definition of limit was required, or why this concept of limit arose in the first place. You would have seen my lecture on basics of mechanics and calculus. So this definition and this concept of limit arose to find out the value of instantaneous speed or instantaneous velocity. In those examples you would have seen that suppose I have to find instantaneous velocity at say time t, something like this, then what I used to do, I used to take this limit delta t tending to 0, I find position at time t plus delta t minus position xt, that is position at time t, and dividing this by delta t under the limit delta t tends to 0. This is definition of instantaneous velocity. And here also you see this delta t tends to 0 was here. Here this is limit x tends to 1, it means x minus 1 tends to 0. And I can assure you that almost all 99% or even more than that, almost all questions of differential calculus or limit or finding the differential coefficient, everything boils down to removing this x minus 1 from denominator. And why? Because you see, when x minus 1 or something like this is sitting in denominator and it is tending to 0, like this x minus 1 tending to 0, you cannot divide by 0. So your all trick, so whatever trick we will be seeing in subsequent lecture on subsequent slides, that trick will be to how to remove this x minus 1 factor from this denominator so that I can find this limit. And this is because of a very simple property I will show you in subsequent class. You see what happened, suppose I had to find this limit of this function, okay? So I cannot put my x is equal to 1 value in this, because the moment I put x is equal to 1, I will get 0 by 0, which is not defined. But I can put x is equal to 1 in this thing. This is a very simple polynomial. So almost all the tricks which we will use in the classes or in the chapter on limits or differential calculus will be how to reach from this step to this step. Why? In this step my x minus 1, this is the villain which is sitting in denominator. I have to remove this villain from the denominator so that I can just put value of x in this thing and get 1 plus 1 as 2 as my answer for limit. Some limit laws, that is, if L, M, C and K are real numbers and L is limit of say a function fx as limit x tends to C. Similarly, M is limit of say a function gx. Then there are different rules, like sum rule, that limit of sum of function is equal to sum of limit. Similarly, difference rule, that difference of function, if you want to take the limit, it will be difference L minus M. Similarly, constant multiple rule, that this, suppose this k is a constant and I have to find limit of this k fx, I can take this k outside and the limit will be kl. Similarly, product rule, that limit of product of two function f and g will be L into M. Similarly, quotient rule, that I have to find limit of x tending to c fx by gx, is it will be L by M provided M is not equal to 0. Similarly, power rule, that limit x tend to c fx to the power n will be ln L to the power n, where n is a positive integer. And root rule, that I have to find say limit x tend to c nth root of fx, this will be nth root of L, or L is equal to 1 by n, where n is a positive integer. And if n is even, we assume that limit x tend to c fx is equal to L. Why it has to be positive? Because for an even function, for if suppose this is negative, then you cannot take say, you cannot have something like square root of minus 4 as long as you are dealing with real numbers. So that's why we are assuming that this L is greater than 0. So these are the limit rules. Another theorem is for limit of polynomials. If I have been given a polynomial px, then the limit of this polynomial x tending to c will be simply you substitute c for all x. So you get an to the power c to the power n plus an minus 1 c to the power n minus 1, similarly like this. So this is very simple limits of polynomials. In fact, in last example also you would have seen when I had to find x square minus 1 by x minus 1, the limit of this as x tends to 1, ultimately by using this factorization and simplification, I change this to limit x tending to 1, x plus 1. Now this is a simple polynomial. I can substitute in place of x, I can write 1, so I get limit 1 plus 1 is equal to 2. And the whole tricks, all the tricks which we will learn in coming lectures will be how to remove this x minus 1 from the denominator, or how to go from this x square minus 1 by x minus 1 this form to this form x plus 1 form. Okay. Similarly, we have limits of rational functions also, that if px and qx are polynomial and qc is not equal to 0, then limit of px by qx will be pc by qc. You see, in this case I cannot apply this thing because my qc is equal to 0 here. X minus 1, if I put x is equal to 1, I will get 0. Therefore, I cannot use this theorem in this question, but I can use this theorem. Okay, now this is a very simple example. Find limit x tend to 1, x square plus x minus 2 by x square minus x. I factorize it, so I get this thing. X minus 1 is common, so I can divide it. Why I can divide it? Because this limit is x tending to 1. The limit x tends to 1 means that this x is as close to 1 as you would like it to be, but it is not equal to 1. X is not equal to 1, so x minus 1 is not equal to 0, so I can divide numerator and denominator by x minus 1. So this x minus 1 is very small, almost equal to say 10 to the power minus 34 or whatever, 0.0000 something, but even then it is not equal to 0, so this division by x minus 1 is possible. Moment I say that okay, your x is equal to 1, then I cannot divide by x minus 1 because it will be 0 by 0, division by 0 is not allowed. So when I say that limit x tends to 1, it means x is going, suppose my 1 is here, then x is approaching this one, but it is only approaching, it is just about to reach there, but it has not reached there, because the moment you reach it, then everything, all this x minus 1 division, everything, your whole edifice, or you can say your whole structure of limit will break, because once you have reached that point, then there is no need of applying this limit formula, because you have actually reached there. So you better apply simple algebra, but in simple algebra you cannot divide by 0, so you will not be able to do this step. So once after this division by x minus 1, I will get x plus 2 by x, and this is possible only when if x is not equal to 1. Then the next step will be limit x tends to 1, x plus 2 by x will be 1 plus 2 by 1, that is 3. So this is very simple example of limit. Some functions where limit does not exist. First of all, you see this unit step function. How this function has been defined? This function is defined like this. It is 0 for x less than 0, so it is here, and for x greater than or equal to 0, it is 1, it is constant. Now does this function have a limit? No, it does not have a limit, because the moment suppose you start approaching from this side, you will reach 1. But if you start approaching from this side, you will be stuck at 0, and there is a jump. There is a jump at this point. Since there is a jump, therefore this function ux has no limit. And this also does not have a limit, because the right hand limit is not equal to left hand limit. This concept of one-sided limit I will explain in next slide, but even without that concept, you can see that this function has got a jump, therefore this will not have a limit here. Now take this function y is equal to 1 by x for x not equal to 0, and y is equal to 0 for x equal to 0. Will this function have limit? This will also not have limit, because this function is growing too large. As x tends to 0, this 1 by x tends to infinity. So it grows too large to have a limit, and similarly for x less than 0, it is going to minus infinity, and for x greater than 0, y is going to infinity, therefore, and it does not stay close to any fixed real number, therefore no limit. Here also no limit, here also no limit. Now let's see this function. This is y is equal to 0 for x less than or equal to 0, and y is equal to sine 1 by x, x greater than 0. So since this is sine function, this is bounded by two limits. So although it is within the limit of plus 1 and minus 1, but this does not have any limit, because as it goes near and near 0, this starts oscillating very rapidly. So it does not keep any value fixed. So it is not close to any fixed value. It will be oscillating between plus 1, minus 1, plus not, and it will be having say value of plus half also, minus half also, plus 1 by 3 also, minus 1 by 3 also. So you cannot say that when it is close to 0, it is close to any real number. It is oscillating between 1 and minus 1. So these three functions do not have limit.